All right, let's have a look at 3D. It says we have a function which is y is equal to negative ax squared plus bx plus c. A, b, and c are positive numbers, and b equals 2a. So on the grid below, sketch the gradient function. Show all values. The y prime intercept, and let's have a look. Oh, yeah, here it is, y prime. Well, we could really write as m if you wanted. Yeah, should be given in terms of b. So just remember for a moment what this actually is. We've got this thing here is a sorry, not cubic, it's a parabola. And it's, of course, listed as a quadratic. So if we had something, and in fact, here's my x value, and I don't really know too much about where this is going to lie on this, but if we had some sort of something that looks like this, yeah, we know if this, we have a graph here, let's say I put something here, and let's say this is m, this is 0. We know at this point here the gradient is 0. So this is a gradient. Well, gradient is 0, gradient, big gradient, small gradient, 0 gradient. So here's the gradient of 0. So that there is our 0 gradient. Yeah. But we notice on this side here, the gradient here is increasing, 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 increasing. So here we actually have really a very, very large, these are quite large gradients here, yes? Here the gradient's getting smaller and smaller and smaller and smaller until it gets to 0. So the gradient's getting smaller and smaller and smaller and smaller. The gradient's getting bigger and bigger and bigger here. So over here, by the time it gets up here, the gradient's going to be very large, yes? So the gradient's going to be quite large, getting smaller still, getting smaller still, until it gets down to 0. So that's what you're going to end up with. You're going to end up with a line that goes like that through there, and this represents gradients getting smaller and smaller and smaller and smaller, smaller and smaller and smaller and smaller until it gets to 0, and there it is at 0. That's m is 0. And we know that's the point where m is 0, where it happens to intersect with this point here. That's really what we're going to be looking at doing. We just have to try and make sense of it with what we've got here. So first of all, we've got this thing here, which is y is equal to negative ax squared plus bx plus c. We're told that b is equal to 2a, not negative 2a, which is all fine. We don't have to worry too much. We could actually just put it straight into here. Or I could just differentiate it and then substitute this in. It doesn't really matter. Dy over dx is equal to negative 2a x plus b. But we're told that b equals 2a, so we could rewrite this as negative 2ax plus 2a, which is fine, except that they want it in terms of b. Yeah. So let's rewrite this now in terms of b. So it means that the differential, the gradient function, or m if you like, we've got a 2a here. We know that b is equal to 2a, so it must be negative bx plus another 2a here. Well, b equals 2a, so another b here. So that's m. M is equal to that thing there. Now let's make this 0 for a moment. Let's find out what happens when we've got the actual turning point. So here's the turning point. We know it's equal to 0. Bx plus b. And it says I add negative bx to both, or add bx to both sides. I've got bx is equal to b. Divide both sides by b. And x would have to be 1 when the gradient's 0. So now we can actually write some stuff here, yeah? So let's go ahead and just again, we're going to sketch this out before we start putting it on here, yeah? So what have we got? We've got... I'll go like here. Here's 1. There's my 1. And we know we've got some sort of a maximum point. Let's call the maximum there. So the parabola is going to turn around this point here, yes? And we know, just like before, it's going to be getting, as it goes here, it's getting steeper and steeper and steeper and steeper and steeper. But it's negative. The graph has to go be negative because this is a negative parabola. So it's getting steeper and steeper and steeper. So it's going to be steeper and steeper. In fact, I'm just going to draw a line straight through here like this. Sorry, you can't see me drawing that. Oh, you kind of see me drawing it. So here we are, it's going steeper and steeper and steeper and steeper, and that's what it's doing. As this goes down here, it's getting much, much steeper. This is very steep here, yeah? Not so steep, not so steep, not so steep, not so steep, and 0. And of course, when it's 0, it's equal to 1. So this line here, we can actually label that line. This is actually the line of, I'm going to label it as, m is equal to negative bx plus b. That's the name of that line. Yeah, here it is. Negative bx plus b. M is negative bx plus b. And we know, of course, when when m is 0, x is 1. But what happens then? What would this point here be? Well, we know this is 1. But this point here, x is 0. Let's find out what m would be when x is 0. Well, we know that m is equal to, if m is 0, b is going to be 1. Here it is, m is 0, and m 0, x is 1. Let's make m question mark. We don't know what it is. Let's make m, let's go m when x equals 0. Here's x is 0. Well, let's put it in. So m is equal to negative bx plus b. This time I'm going to make x 0. So m is equal to negative b times 0 plus b. So m is going to equal to, m is equal to b. So this point here is when m is 0, when x is 0, m is b. When x is 0, m equals b. Or if you like, y prime equals b. Or dy dx is b. But that point there is b. It passes through 1. And the gradient itself, the gradient function is negative this. Or you could say y prime if you want. You could say y prime is equal to negative bx plus b. Or you could say dy dx is equal to negative bx plus b. Whatever you like, yeah? But that would be the name of that line. So let's go ahead now and write that all in. By the way, we do not know how high that is, yes? Mainly because we don't know how extreme the A's and the B's are going to be that's going to leave us in that situation. So let's go ahead and do that. And I'm going to call this point here 1. There it is. I'm going to call this point here B. There it is. So I'm going to line all that up now here like this. And I think our intentions are pretty clear with what we've done here. Arrows on both ends. You can label the line y dash is equal to bx minus bx plus b. And that's what I would draw. So this is how I would essentially find out how those parameters work in terms of finding how we would label these points here. But you've got your y, you've got your x, y dash, your y prime there, and that's how I would draw that. Hopefully that makes sense.